Hi, my name is Rich McFarland. I am the technical trainer for Fieldpiece Instruments, and today I'd like to show you a little bit about the SMAN4. The SMAN4 has 4 ports. Now I only have 3 ports hooked up. This is for your 3/8, so you can pull a deeper, faster vacuum. It also has 4 valves instead of the 2. So we have the vacuum, of course, and the refrigerant, and then of course your low and your high. The other feature about the SMAN4 is it is wireless. So we're going to go ahead and turn this on, and you can see the large display. I do have a backlight that I can go ahead and throw on here. It has the most common refrigerants on that are listed together. For instance, there's R22 for air conditioning, and then R410A for air conditioning, 134A for refrigeration, and 404A for refrigeration. It does have a lot of other refrigerants listed as well, as I could just go ahead and scroll through. But those are all together, so you don't have to scroll through and try to find them. We do have this on PSIG. We do have this on superheat and subcool. So we've got superheat and subcool. Then we have T1, T2 to direct. That's these. So you would put this on your suction line, and then this one on your liquid line, and you can read those direct. Then we have your vapor line saturated temperature and your liquid line saturated temperature, and of course indoor wet bulb and outdoor dry bulb. So what we're going to do is I'm going to show you how to sync this up with the accessories that we have here. What I've done is I've taken a ET2W wireless transmitter that's there, and I've used an ATH4 dual temperature head. Now we're only going to use one temperature, as we're just going to use this for the outdoor temperature. Okay, so basically plug it in, real simple to do. And then we also have with this as well a transmitter, the ET2W transmitter, and an ARH5 head. Now the accessory head on this is an induct psychrometer. Alright, so what I'm going to do is show you how to sync the SMAN4 to the accessory heads and wireless transmitters. So we're going to go ahead and turn that light back on so you can see this real easily. In order to get to your dry bulb and wet bulb settings, just hit the round button until you come down. You can see T1, T2, which is of course for these, and then we'll go down to their vapor saturated temperature and liquid line saturated temperature, and then we're going to go ahead and we see IDWB and ODDB. So at this is the point where we need to be, and I'm going to go ahead. At this point you'll see the arrows here. I'm going to hit the down arrow and you'll see the IDWB flashing. So I'm going to go ahead to the wet bulb, which would be this right here. We're going to turn the transmitter on, and then we're going to go ahead and turn the accessory head on, and we want this on DC. We're going to go ahead and hit the sync button, and hit the sync button on this for a second, and you can see that it was hunting and it finally found the temperatures. So we go ahead and see at this point that the OD dry bulb is actually flashing. So we'll do the same to it. Go ahead and turn the transmitter on to DC, and then go ahead and put it on T1. You could do T2 on this one because I have 2 hooked up. Hit the sync button, and then hit the sync button on this, and you can see that it's been hunting. It will find it, and it shows that it is 65 degrees down here with a 57, 58 degree wet bulb temperature. We can see that the temperature for the wet bulb is changing as the air is going across it. So now what we're going to do is go ahead and go out to the outside unit, and I'm going to go ahead and put my outdoor thermometer out here, and it's about 43 degrees outside, so I'm going to use this jacket. What I'm going to do is just pull this taut, and then I'm going to start to draw this closed. Now you can see that this is an irregular shape, and this is working quite well. On R22, you want to be between 100 to 145 psi difference between the low and the high side, and on 410A, you want to be between 160 and 220. It's pretty chilly out here, so I wanted to show you can do this in cold weather. Our outdoor temperature right now is 39 degrees. I'm going to go ahead and close this up a little bit more. You can take a look at my pressures now. We're looking at 47 on the vapor line and almost 177 on the liquid line. And also take a look, we're at 47 for our indoor wet bulb, so we are communicating with the indoors, and 41 on our outdoor, so we are remotely sensing the temperature for our outdoor temperature, and we are within specs between the 100 to 145 psi. I'm going to scroll down through here and show you this. Our superheat is at 15. Doesn't matter, this is TXV and it's pretty darn chilly out here anyway. And our subcooling area right now is 15.9. So we'll scroll down a little bit more so you can see that our temperature of our liquid line is 76.6 and our vapor line is 38.9. And you do that one more time, we're looking at our vapor and liquid line saturated temperature. So this is really easy to do, takes all the guesswork out. You know exactly where you stand and what you would need to do to correct any problems, or if it's running perfectly fine. So you can do this when it's really cold, as it shows right here, 41 degrees outside. So you can do this all the way down to 37 degrees.